So today we'll be talking about PHP unit testing at Tagged. Just out of curiosity, how many of you have written a unit test before? Okay. How many of you have written a PHP unit test at Tagged? Okay, some of you. So that's good to know. So the goal of this presentation, we're going to try and start with gaining some familiarity with unit tests in general, and then how we're doing them here at Tagged. Gain some familiarity with the framework that's set up in place. There's a lot of pieces, but hopefully they help you make writing unit tests easier. And then we'll do some, hopefully learn to write tests or write better tests. So we're going to start with just talking about general unit testing attributes. And then we'll look at what we currently have. So how to run tests in PHP. We'll talk about the assertions. We'll talk about mocking objects. We'll talk about mocking static functions, and then getting references to the real objects under test. Finally, we'll just go through and we'll talk about a little bit about Hudson. And then I'm going to be talking, doing a practical demo in which I'll be writing some unit tests for Wink. I think that the best way to learn unit testing by far is to just do it. Write some tests, make some mistakes, and you'll learn a lot from every mistake. You finally understand what went wrong. The second best way is to watch me do it and learn along as I went through this before, so these should work eventually. And then if we get to it, I have some slides on effective testing strategies and test-driven development. So, a unit test. A unit is the smallest testable part of an application. Oftentimes it's just a function, maybe it's a group of functions, hopefully not too big. Big things, hundreds of lines of code, are very hard to write unit tests. Ideally you want to have a small unit of code that's easy to understand what the inputs are and what outputs you should expect. The test exercises this piece of code in isolation. And it's good for regression testing because once it passes, then it should always pass. And if it fails, then you know your code has regressed and you have a bug somewhere. Each test should be independent of any other unit tests, including itself. Shouldn't matter how many times the test gets run. The state should be set up at the beginning as being in a controlled state, and so, yeah, no dependencies in that way. The number of times they're run shouldn't matter. You start with a controlled state and you give it controlled inputs to this piece of code you're testing, and then you should get expected outputs, and you can make assertions to ensure that those outputs are correct and that the state of this object should, or whatever piece of code you're testing, should change in predictable ways. And one of the big ways we do to ensure that our pieces are independent is we mock out any external dependencies, like the database, like the cache, like any external services, and we sub them in for stubs or mocks, or basically fake objects that return predictable results. So in our PHP codebase, all our tests are found here in cooltest/unit/test, and this is how you make a file that our framework understands. So it ends in test.php. Every test is a function within that class that begins with the string test. They're run in some order, and running is, we call a setup function to do some state setup beforehand, and we call a teardown function afterwards to clean up after ourselves. And we want to clean up after ourselves so that the next test that runs starts with a clean slate to begin with. So just this template of a class, my class test.php. If we were running this, we'd call setup, and then we call like test method A, and then we call teardown, and then we call setup, test method B, and we call teardown. We're extending from this class test_base, which gives you a lot of sort of basic testing functionality and a lot of the stuff that takes like a lot of setup to do, setting up your initial state. We just have a lot of functions to help you do that. And then running the tests, we're going to do it from the command line, and you just navigate to whatever directory your test class is in. PHP Unit star will run everything, or dot will run everything in the current directory. If you want to run all tests in a particular class, you can name it, and you can also use a filter option to filter on whatever string you want to match. So you can, if you have 12 tests in your class and only one of them is failing and you want to run that one test over and over again, this is how you do it. So you don't run all the tests that you know are passing while you're trying to debug. Assertions. So I'm familiar with any testing framework has what we call assertions. Some languages just have an assert with some expression that evaluates it true. Our framework has a number of functions which are basically syntactic sugar on top of that, so you can assert that something's true, that it's false, that it's equals, that it's not equal, that one value is greater than another, and I think these make for easier tests to read. And then we have the assertions also take an optional message which is printed every time it's failed, and I think good tests have good strings written for failure messages so that when the test fails, you have some idea of what went wrong and some idea of what the test author thought was supposed to happen or what might have gone wrong. So now we get to some of the interesting parts of our framework, which is how to create these fake objects to create our controlled state. So one of the ways we get references to most of our objects in our code base is through this $_tag global loader, and what that does, it uses a config array and figures out how to generate the object and get it for you. So whether it goes to memcache or whether it has to create an object directly from the database or whatever, there's a bunch of details. So what we do instead is we create a mock object which is just like the real object that you expect to get from there with whatever differences you specify. So we override methods, we override properties and constants, and then we stick it in there so that when your code makes a reference to $_tag whatever, you get this fake object instead of the real one. So for example, here is in an API file we have this function getGoldBalance, which gets this $_tag gold with passing in the user ID, gets a user gold object, gets the balance, and returns it. Simple. So in our test file, what we do is we go to this global mock factory, get global mock. We pass in the class name of the object we're trying to mock. We pass in the config, which is just the part after the arrow and the $_, and then we pass in whatever arguments in each bracket afterwards. And then we have this function where we override the method getGoldBalance so that it returns this balance, the value of our balance variable, 500. So every time you call that method, no matter what object it normally would have gotten, now it should return 500. And then we mock it, we make this API call, which then calls this function. We get a fake object, return the results, and at the bottom we see that we should assert that the balance equals the result of our API call. And if it's not, then something's wrong with our test. And then here's some examples of overriding properties. So if we override the myProp on this fake object, whatever, myProp should print 1,000 when you do an echo, and the same with constants. It doesn't come up a whole lot, but it is often useful, especially when you're trying to test something where the string is less than 1,024 characters, and creating a 1,025 character string is kind of a pain sometimes, so you can bring it down to some normal usable value to write your test. If you haven't written a test here in a while, this is one of our newer features where we're able to mock a static function. So a call such as tag privacy can communicate. Now we can say that the result of that function call is canned. So in this point, we just mock it so it always returns true, and then we can assert that it always returns true no matter what arguments we give it to. A more interesting example here, we have this tag user auth isBox user function, and then we can say that if I pass it in the bad user ID, it returns true. Any other user ID should return false. And these assertions would be how you would ensure that. Another feature that we have that is useful when you're doing negative testing, which is where you're testing that giving bad input deliberately and figuring out that something should happen, like an exception or an error should be raised, is we have this test error handler, which we can use to suppress errors within a certain class, and then we call the code, and then we can assert that an error was actually suppressed, and then we clean up when we're done. Finally, when we're talking about code under test, we don't actually want to test mock objects. We want to test real objects. But if we just do something like $_tag context user ID, our test could be at the mercy of whatever might happen to be in memcache or in the database at that point. And that kind of sucks because that can change, and we all share the same database and memcache in dev. So what we instead do is we call this get global object function, which basically figures out how to create the class that you want to get and gives it to you without worrying about whatever might be in memcache or in the database. You get a fresh copy. You're guaranteed that it's not going to hit any external services. And so I'll show you some examples of how we use that in a second. A couple sort of interesting notes about things we can't do in our framework. You can't pass these what we call use variables by reference to overridden methods. If you can understand what's going on here, it's basically we're passing a variable into the context of the method by reference, so that when we call this method over and over again, we expect the balance to continue to increase. And because of the way our mocking framework is constructed, that isn't possible. So it won't work. Sorry, you can usually write a test just fine without it. A little more ornery is we get this, we can't mock static functions that also contain static variables. And here's one that's actually in our code base, this is school supported function that has this static country supported array held right into it. And because of a bug in PHP actually, that if you try to mock it multiple times, you end up causing a seg fault, which sucks. So for now, we can't do anything about it unless somebody would like to hack on PHP for a little bit. And I also included this whole code snippet just as an aside. It included this thing at the bottom that I really, really hate, where someone tests if condition, return true, else return false. And I hate when I see that, and don't do that. The person who wrote this no longer works at the company, so don't worry. Hudson is responsible for running all of our unit tests on every SVN submission to web. Currently we have over 900 tests. And if any one of them breaks, we get an email to proddev@tag.com, as well as to whoever had commits on that current submission. And so it's nice and public. So if you break it, please quickly respond to the list to say that you are investigating, and please fix it. So whether it's the unit test that broke or the actual code, and we do catch bugs with this from time to time, we want to make sure that this is fixed before we try and release the next day. Just a screen showing you what Hudson actually looks like if you haven't been to the dashboard. On the left there we've got the current builds, and you can click on either one and sort of see the results of the builds. The red ones down near the bottom were failures. And then you can click on the thing like Clover HTML coverage report is actually pretty interesting. If you're trying to write unit tests, you can see how much code coverage you're actually achieving with your tests, and it shows you down to the percentage of lines, the percentage of functions, the percentage of actual classes that are considered covered. And there you go. That's what it looks like. So this is what our coverage actually looks like. Some of the things like Meet Me are nice and covered. Others like GIFs and Love Oracle aren't covered at all. So we should work on that. So now I'd like to do an example. So we'll see what we get through here. So I'm going to write a couple little tests, and this is just how I write unit tests. And you start by just writing something simple, and then seeing what sort of running the test, seeing what errors you get, and improving until everything passes. So let's see. I should start with you can see all my terrible typing. start by calling the parent setup method because there's important things that happen or may happen in there, so I want to make sure that that happens as well. Let's just set ourselves up some variables we can use. I like the integers in the 9,000 range as fake user IDs because they're definitely invalid. And we'll set up a wink object here. Okay, so now we've got an object, and we can write a test around that object. And we'll start with something simple. We'll just test the count winks function. And, you know, so there's a simple test that just creates an object and calls a function on it, and then we can assert that numwix is some value. So we can, you know, at the very least write I think that's a PHP function. Let's go ahead and run this. So go here and well, it passed, but it also gave me this huge call stack. And the reason for that is that I didn't do anything to stop it from hitting the database. So it made a whole bunch of calls, and these are right here. This is a big call stack warning basically saying you hit the database, so don't do that. So we'll go up here and we'll set up a mock object for database. So let's see. So getting our class name, tag_wink. See, maybe it's helpful to look at the actual function here that we're calling here. So this is the apps wink under test here, this function. So it's created by just passing in a user ID, and that's all the construction does. And then count all winks basically does this load all winks function and then counts it and returns that value. And load all winks down here gets the DAO and then calls the gets wink function on the DAO and then does some processing on that data and sets it to cache. So that gives us an idea of what we should be creating, which is I go ahead and create this DAO function, tag DAO wink. I wish this really rolled over. Okay. And the method we want to override is getWinks. And we'll just here we'll just create a function that returns and I'll save you some time that I looked earlier and figured out what the return type of all this was, so I'm just going to sort of type this out. I really should have copied this. And here, it'd be easier to just write time, but whenever I write PHP code, I like to use this variable that's always set in your PHP functions called server request time. And the reason I use this is that throughout a PHP process, this value be constant, so that if I wanted to test whether the time set was correctly, I can test and know that this value will always be the same, and I don't have to worry about whether my current test passed the second mark in the time counter, basically. And the type is R, which is received wink, and let's say is viewed is no. So we overrode that function. Now I have to go ahead and actually make sure that I mock this guy. One new change that's been introduced relatively recently is that you no longer have to unmock anything. Anything you mock should get unmocked automatically for you, so you don't have to worry about cleanup anymore, which is really nice. Let's go ahead and save that and see if that helps. Oh, call stack. What did I get? Of course, live demos cannot. Fun times. Okay. Let's see. What did I do? Oh, okay. Fortunately, I ran into this error yesterday, and I know what it is, because it took me half an hour to figure out. Using a variable before you've defined it. Okay, so that passes. We still get some call stacks here. This one is warning me that I haven't mocked this user. So let's go ahead and this is actually how it is to write unit tests. You start by just doing the simplest thing you can, and then you get a bunch of errors, and you actually just have to go through and iterate to remove them. Yeah. So you're seeing it in all of the gory details. Lucky you. So fortunately, I have this helper function that I've written called mockUser, which should automatically make sure that anytime I call a user object, I get this fake valid user. And I can pass it some configuration to give it all sorts of state, but for now, this should serve my purposes. Getting better. What'd I do? Oh, looks like I called, let's see, tag.link get winks. Okay. Shouldn't call the database. Oh. Oh, I did the. That was my problem, is that I got the name wrong. So that was not part of the plan, but that's one of the things that it'll still let you do that. And when I get the name right, there we go, it passes, no errors. Test is correct. And I should be able to now do things like should be able to assert that the number of winks is 1. Hooray, it passes. And if I were to do, that's clearly not correct. Failure. See? And because I didn't change my not an integer message, I got the wrong message, but and now if I run it again, it should fail, but I should get a useful error message with my test. So I realize I'm getting kind of close to the end of my time, but hopefully that was useful to understand the sort of process of what's going on. So back to the slides. We'll just run through the last few. And here we go. I just wanted to talk about other testing strategies for writing good tests. corner cases are one of the best ways to sort of make sure that your code is correct, because this is where most of the errors we make as programmers. Bad input like 0, null, empty strings, empty arrays, large numbers, both positive and negative, big strings, anything that looks wacky or weird, or these are good places to start writing your tests. The normal expected input should always pass because that's what you wrote, but maybe these are things that you or whoever wrote the code you're testing didn't think about. Negative testing is another good way to do it, in that if we give bad input to a function, say a gold transaction ID of 0, we should get an exception. It should get bad output. So we can assert that we get an exception wrong with 107 in this case, and if we ever get to this point, we should just fail the test immediately, because this call should throw an exception. And then I showed you the example earlier with testing for errors. Another good way is to set up your test with differing initial states. So this theoretical class friends we have, we give it a friend list to begin with, we get a random friend, and we should be able to assert that that friend that we got is in the friend list that we started with. But what if we had no friends to start with? Then the random friend should return null. And if it doesn't, if it returns some other value or raise an exception, then you've got a problem. We'd like to make the test functions that you write as granular as possible. So here we have this friends object, we add a friend, we assert that it's part of that object, and we should stop the test right there. We have I've often seen people that says, all right, we have an object, friend object, it's already got a friend into it, it's already set up, so let's now remove the object and assert that that is also a friend. But what happens is if this first assertion fails, the second test never runs. It basically throws an exception and you're done. So if you have a problem also with this remove function, you'll never know about it because it's masked by the first assertion failing. So these should really be set up into two separate tests. And another thing is that, and this is something that you'll naturally learn the more you write unit tests, because it'll become really annoying, is you want to make sure your tests are written are implementation sort of agnostic. So this is bad. You shouldn't have constants like 10 out of nowhere here. You should get them from somewhere. That should be either part of the state you set up initially or some basic definition of configuration or something else like that. That way, then, if somebody changes this value results per page to 20, your test doesn't break. Finally, I just want to talk about test-driven development. You want to, so one of the nice ways you use, you stub out the methods for your class first, then write unit tests. At first all the tests fail, and then you start with the testing framework to say this is what my class should do. Then you write the class, and when you're done, all the tests pass. And this is also really useful for bug fixes, and I've done this where the function's broken, you don't know why, so you write a unit test to figure out this is what the function should do, and then when you fix the bug, the test passes. It's a really nice way to know that, verify that your solution is correct. Finally, I have just a couple notes on writing testable code. These modularizing methods using getters and setters and passing objects to a classic constructor can also be really good, but I want to talk about avoiding these, which make it really hard to test, which is like big giant functions that are 400 lines long, and it's really hard to write a unit test for a 400-line function. It does so many things that it's hard to sort of nail down what exactly that function does in a concise unit test. And this last one, creating objects within methods instead of asking for them. I see this line all over a code base where even though I can mock out tag email send, I am creating this tag email objects function right in the middle of it, and I don't have any way to sort of mock that. So Andrew has recently written a function that basically is a very thin wrapper, send with options around this, and that's something that makes it much easier to test your code. And that's all I've got. So thank you very much. Do you guys have any questions about unit testing, about process, about anything at all. Yeah, Don?
So what are the scenarios that the teardown must be called?
I'm sorry?
What are the tests that the teardown must be called?
Oh, so Teardown should do all of your cleanup for you, and right now it does almost everything sort of, we've set it up so it does a lot of things automatically for you. So for the most part, you shouldn't have to call it. You should just make sure that as long as you're inheriting from test base, it should take care of all of the unmocking things for you, putting all the overridden configuration variables back. I don't think there are too many instances where you're going to have to use it at this juncture. There's a lot of older code that does, and if you do find the need to, just be sure to call its parent function first.
You say the setup method was called in between each test? Or
prior to each test, yes.
Is there a way to make it call it just once for all tests within the class? Like a setup before class or something like that?
No, and I don't think you'd want to do that because you want to make sure that each test is independent. Yeah. So you don't want to depend on it having been called beforehand. If you have a specific case where that might be useful, then we can talk about that. And because I've been wrong before about what things a tester might need or might want. So this whole framework has evolved because people have come to me with, I can't test this code, this sucks, can we do something about it? And then we did, for the most part. So it's continually getting better, and that's because developers keep working on it to make it easier on themselves. Anything else? Barrett?
So where can we go for sort of the latest good, clean examples? You mentioned there's a lot of old code that's bad.
There is a lot of old code that's bad. Good, clean examples. The elections tests are better than most. They tend to be newer. I would look at tests written newer rather than older. I should probably have go pick out examples of tests that I really like and put them up on the wiki. There's a wiki page that has a lot of this information on it, and I should just link to examples of what I think are really good tests and make sure that's kept up to date. Because yeah, there's a lot out there, and it's hard to tell what's good practice and what's not. I think the more you do it, the more you'll learn about, like, this was annoying to write, whereas this was much easier, and you'll start to figure it out. But examples are always a very good place to start. So yeah, I should do that. Anything else? Go ahead, Barry.
So you mentioned test-driven development.
Yeah.
So if I write a whole bunch of tests before I start coding, they'll all fail and break the Hudson build?
Well, you don't have to check them in.
Oh.
Yeah. Yeah, please don't check in broken tests. It just annoys everybody. Jeff?
Is there an easy way that I don't have to put a bunch of test data in my setup method?
You have to put it somewhere, but you don't have to put it in the setup method. The elections test, and I think cards are doing this as well, and I didn't have time to sort of demo it because it's a lot of code to show, but you basically set up a config, and within the test environment there is a variable called $_tag_test, and if you define things in this config array, then basically those will all be accessible via that array, and you can sort of use that to store all of the, basically set up a whole world. So for elections, we've set up basically is a huge file with fake projects, fake users, fake objects of all sorts, and within that context, then we test against everything, so we don't actually have to depend on anything in the catalog, even. Cool. So you guys gonna write some unit tests? Despite the fact that we have 900 of them, our coverage is still something like 33%. There is still a lot of code out there that, for example, like Wink, there's no test for. I mean, Wink's kind of a trivial example, but there's a lot of code out there that has no test for it, and it could really help because a lot of the times, just running the code, whether or not you have any good assertions on it, just running the code catches things like typos and undefined variables and things like that that would cause problems, but that you can check in without noticing. So it's just a very good way to have a first pass sanity test to ensure that the code even runs, because we don't have a compiler in PHP. Okay, thank you very much.